Hello, today we will discuss CI/CD and big data. Let's start off with an example. Suppose you're graduated and you're working as a software developer inside of a certain company. You will be assigned to a project with multiple of your colleagues. Most of the time you will be working on your own smaller project where you're developing some parts of the code for the general project. At some point you will combine the code and later on upload it to an Amazon Web Services environment. After uploading it, which is also being done manually, you will have to test your code inside of this environment. Since none of the code is perfect from the beginning, you will encounter a bug most likely. And the best way to cope with this is to develop a test case. What this test case does is it builds a test that will check for a bug that you've recently encountered. So in the future, you're more robust for the next versions of your code. And then, once you've finished developing this test case, you'll have to, of course, after every change, upload your code again, manually, of course. And most frequently, you will encounter a different bug, and of course, you will develop a test case for that specific bug as well. So, as you can see, this involves a lot of manual work, and of course, is a very slow process. So, let's take a more deeper look at this problem itself. You can clearly see that the problem is occurring inside of this loop, this sort of cycle. And this is where CI/CD comes in. CI/CD basically is a solution to this problem. And what does it do? Well, it automates the build, the test, and the deployment of the code itself, which of course leads to a way faster and more efficient process. What are the principles of CI/CD? Well, the first part, CI, stands for continuous integration. This means that all the code changes are being done, tested, and built automatically. And once they have been tested and built, then they are being merged. And then in the next part, the CD part, which means continuous delivery or deployment, the changes are being shared to a shared repository almost immediately, which of course speeds up the process. Now, what is the architecture of the CI/CD? Well, first of all, you have the SCM, which is the source code management. This is basically where all the source code and data is being stored, for example, like Git. Then you have your CI server, where the testing, the building, and the integrating of the code changes are being automated itself. And the next part of the next building block, let's say, is the build server. This is where the actual code is being built. And after that, you have the artifact repository. This is basically the storage of all the deployable artifacts. These can be things like executables or libraries and other things. Then you have the CD server. This is the continuous delivery or deployment. And in this part, the deployment of the code is being automated as well as the code changes throughout the process. This is being done, of course, in environments such as Amazon Web Services. And of course, the last step is to test the automation frameworks. In this case, you're automating the testing of the application inside of the environment. Then, why would you even use CI/CD? What are the actual benefits? Well, first of all, it reduces the risk of bugs. Because of these test cases that you develop and that are being automated, every time you change the code, the probability of a bug occurring will lower because you've built in these automated tests. So it will reduce also the time, and this of course leads to way faster improvement. It accelerates the improvement of your project. And if you combine these, then of course it leads to a faster deployment of your general code itself. The fact that you can meet the deadlines way better because you don't have to do all the uploading manually and the testing manually.
Now imagine you want to set up CI/CD for your big data science project yourself. What do you need to do? So first of all, you need to get a version of control system like Git, like most of you know. These are essential for managing the code and data changes in the data projects. They allow you to track and collaborate with team members, and you can see the history of the project. Then next, you need a CI/CD platform. So these platforms are basically what you just saw in the architecture. They automate the process of integrating the code changes, running the tests, and developing models. Some popular platforms are listed here: Azure DevOps, GitLab CI, and Jenkins. Then last, you can use these frameworks to enable you to train and evaluate machine learning models efficiently by integrating these frameworks into the CI/CD pipeline. You can ensure the models stay continuously updated and validated. Then now I will give you an industry example on how you can use CI/CD and how it is being used. So this was an industry example we found online where a team tries to help a retail client resolve their tickets automated using machine learning. So when one of the users or a maintenance problem raises a ticket, the machine learning will classify the tickets into the different categories, and this will help to foster resolutions of the tickets. Then how this works is listed here on the slide. So first, the pipeline is built using Azure DevOps. So these are all the things they need to do before they can use the CI/CD workflow. So then the build pipelines, they generate a model artifact from a candidate source code. Then these artifacts are deployed into infrastructure targets using the release pipelines. Then the release pipelines move these artifacts to the quality assurance stage or the QA stage. Then, and this happens after they have been tested in the development environment. Then after this, the model testing happens in the QA stage. This is where they do A/B tests and stress tests. The A/B tests are tests like when they change one thing and then they see how it reacts, for example. And the stress tests are just to test the robustness of the code and how good it is. Then lastly, a human validator, usually the product owner, ensures the model passes the tests and they have been validated, and then he approves the model or he doesn't to be deployed to the production environment using the release pipelines. So after all these steps, they can deploy the CI/CD, but then the work doesn't stop because it also needs to be maintained. They do this by setting up some cron jobs. These are some Unix commands. They monitor data drift and concept drift. These happen on a weekly basis, so the pipeline can be triggered when an unacceptable drift occurs that requires retraining of the model. And then the second thing they need to do is to monitor the performance of their CI/CD pipeline in production. And they do this by inspecting the pipeline releases in Azure DevOps pipelines. The purpose of this inspection is to ensure the pipeline is healthy and in a robust state. Some guidelines they keep by doing this are integrating automated acceptance tests and auditing system logs and events periodically.
Now we are gonna discuss the most important tools used for implementing continuous integration and continuous delivery. For continuous integration, the main tool is Jenkins, which use repositories like GitHub, GitLab, or Bitbucket to implement the continuous integration. And other alternatives are Travis CI and CircleCI. For continuous delivery, the most useful tool is Spinnaker, which create a pipeline system which manage all the process of distribution to major providers like Azure, Microsoft, Amazon Web Services, or Google Cloud. Other alternatives are GoCD and Concurs.
So this was our video about CI/CD and big data science. Thank you for watching.